Okay, thank you, everybody. My name is David Sparks. I'm with the Texas A&M Transportation Institute, and they asked me to speak on this topic here, and what I have in here are a few things, kind of where we're heading. So I'll go into some explanation about connected and autonomous vehicles, and then where we are today, using 3 case studies to illustrate that, and that would be tolling, traffic management, as well as parking. So you can kind of get an idea of where we're going, but what the opportunities are today. So that's kind of a long name for a session, but really what we're talking about in all this is safety and mobility. Those are the key pieces, but that's not really new. Safety and mobility have been integral parts of transportation networks and systems for a long time. So traffic management and ITS, which is referred to as the acronym for Intelligent Transportation Systems, that includes tolling, border crossing activities, fleet tracking, we just heard a lot about that, access control and parking, and also the interaction with pedestrians and bicycles on the roadway as well. I'm not going to go into any information on this dealing with privacy and personally identifiable information, cybersecurity, distracted drivers, accident stats, legal and law enforcement, because all these things have to happen inside of an ITS environment for them to be effective. So who are the players in all this? And think of this as maybe 2 groups of players. The primary players would be the folks on the road. So those would be the road owners, who owns the infrastructure, who's responsible for maintaining it, the drivers of the vehicles, and the vehicles themselves. The other players that are involved in this ecosystem are kind of secondary in nature. They're not on the road participating, but they're behind the scenes. So think of insurance, technology and service providers, construction industry that may be involved with building and maintaining the highways, traffic operations and maintenance, fuel, power, etc. So when you think of all these things and kind of the emergence of connected vehicles, there's a lot going on in this space, and through some work we did, we kind of categorized everything that rolled up into 6 categories or 6 groups. Obviously, you got policy, regulations, public awareness, and outreach. What are the rules of the road? What are people going to need to be understanding on how they operate, their traffic and vehicles? We heard some prior speakers talking about truck platooning and people cutting in between those. Maybe that'll change someday to where platooning trucks have the exclusive use of the left lane, so that they don't have that kind of interruption of their traffic that could cause some problems. The second group, in-vehicle systems, this is also known as ADAS, Advanced Driver Assistance Systems, but these are all the processors, sensors, actuators, and other devices that are in the vehicle that are helping control that vehicle and its performance and its trajectory. The third group is communications and data sharing. So this is all about the V2X discussions, DSRC, cellular emerging technologies, especially 5G that people are talking about. This is how the vehicles are going to communicate with each other. Road readiness. Think about the future of building new roads and what's going to be involved with them. Humans can see a lane pretty well, but unless you have good lane markings that have a lot of retroreflectivity, you're going to have machine vision have difficulty seeing what lane you're in and so forth. Interestingly, there's starting to be conversations about, when you build a new road, once you get into the right penetration of autonomous vehicles, you don't need the width of the lanes that you do today because of drift, and obviously you're going to be able to platoon vehicles in a way that's going to increase the wear and tear on very specific roads. So it's almost like your car is going to be able to join up and think of it as a train of cars or a train of trucks, which are the platooning topics you've heard about just a few moments ago. Standards, those are important, especially across all these areas, because people need to know what to expect, and if you're developing and providing some of the technology, you got to know how you're going to communicate with others in the market. And procurement, which is kind of an interesting topic when you get into a technology or an IoT environment. because the life cycle and the span of the procurement processes for road infrastructure owners, which are typically state agencies or local agencies, they have a much longer procurement process. And I can tell you from an ITS standpoint, it's not unusual or has not been unusual for some people to compete in the procurement, win the job, and before it's all rolled out, it's been leapfrogged or some newer technology is out that, if the road owner said, oh, if only I could have, updated that, process. And so you have a life cycle of technology procurement that our public processes are going to need to, catch up with. So that kind of brings us all to IoT. And this is not new in transportation. All the traffic management systems, those are all tied back to SCADA principles, supervisory control and data acquisition. Same with utilities. So, we've been tracking traffic flow, we've been tracking queues, and when you see different events, you're able to adjust traffic signals, for an example. Or speed may vary based on different traffic events. But what has happened is as the technology, Moore's law impacts have kind of come to transportation, it's been able to drive much quicker adoption, and you're able to measure more devices and more things that you can start developing a payback with. So a lot of what has gone on and what people are always challenged with is how do we, what is the return, what is the payback in this space, and really kind of understanding the different domains. So with that, I kind of want to go into a couple case studies. What I think I'll do for time is I'll go through these first, and then hopefully y'all will have some questions you'll want to ask. But if anything jumps out at you, just stick your hand up and I'll stop and we'll cover that. So the first case study I wanted to go through was tolling. And this here is electronic tolling, and some of you may have seen situations like this. This is a gantry. It's a structure over a lane that has a lot of sensors and communications equipment in there to do a variety of things. One of the things it has to do is identify everybody who's using that toll road, because you're collecting money. So the payback and the return is money very quickly on this, and it's a very high degree of accuracy. So when you get to 4 nines, you're talking about no single points of failure. You can't just have a gate there and stop the traffic as it's going through because you didn't read their tag correctly, and therefore you can collect cash. You don't have those options. You got to capture everything. So the way these typically work is this vehicle, as it's driving under it, has an RFID device, and it's having an image taken of it, including a license plate image. So you get all this data in this image around this vehicle that, because of the sensors in the road, it's going to say, I just saw an 18-wheeler go through, or I just saw a truck, a smaller truck, or I saw a passenger car, and it's going to create a packet of information and say, here's the event that just happened, and then it goes through the billing process, and all that gets handled in a back office. So we're talking about systems that need to be very available and very reliable all along the way. We talked about the sensors to capture all those events, and then the data processing that goes on in a back office with the network to pull it all together. There's no single points of failure, no data loss is allowed, and I'm saying no because on a practical level you have to design the system and operate to try to reach those levels if you're going to get close to the level of your contract obligation. And you got to be able to report unusual occurrences when they happen. So that's kind of an idea on tolling. The second group is going to be traffic operations and traffic management. So here what we're doing is you're not worried about 99.99% accuracy because you're collecting money. You're wanting to make sure the traffic is flowing as efficient as possible, which is somewhat qualitative. It's based on speed limits and vehicle counts and time of day and a whole host of other things. And there's a term of art that refers to level of service in traffic. And if you're at level service F, that means, what you think it means, that you're not moving very quickly as you would have expected. But obviously you don't have to know every vehicle and every transaction going on and what that flow looks like. You just want to make sure that you can provide a level of service. You have field devices that help measure that. So that could be speed cameras, it could be Bluetooth sniffers on the side of the road that are helping measure travel times. Obviously, you have signals that might be involved, from an intersection standpoint to manage safely, intersections. All data then is collected and brought back to these command centers where, mostly this is from a review and oversight standpoint, and if there's an incident that occurs, you're able to dispatch emergency vehicles if necessary. If you immediately detect that the flow has degraded significantly, the video wall will zoom in on those areas and help give you a visual so that you can dispatch the right emergency vehicles if that's necessary. And there's a whole host of detection metrics that are involved to help identify all this. So again, these are all kind of SCADA that are now Internet of Things, and these have all improved with the technology that's now available today. The last case study I kind of want to talk about is parking. So this is a little bit, this has all the elements of tolling where you want to collect and be highly accurate with the billing function. However, you're able to not have to deal with high speeds and flow in a way that helps create a little bit more precision. So you're using a host of sensors to identify who's parking in the space where they're captured. Obviously you want to generate the maximum revenue you have, so if you're the parking operator, you want to make sure you account for everything that's going on in that space. All the sensors and ways things are done today, you can automate that instead of having to have enforcement personnel walk around and chalk tires. That's where, if you have a 2-hour parking zone, somebody comes along and puts a chalk stripe on your tire, and then they come back 3 hours later, and if it's still there, you got a ticket. And then obviously integration with other systems like Department of Motor Vehicles. So if you get parking tickets through municipalities, you have to pay your fines or else you may not be able to register. So a whole lot of different use cases and all that. So, but that's today. So that's if you want to dive deep into what's going on today. But again, thinking back to where things are heading, you've probably heard about the proving grounds and that are involved with proving autonomous and connected technologies. So there's 10 areas in the state. There's a couple in California, Pittsburgh, and other locations, North Carolina, Florida. But there's 10 in total and one in Texas. And this is a consortium of a bunch of cities and universities where TTI at A&M, here at UT in Austin is the Center for Transportation Research, and Southwest Research Institute are the research agencies along with these cities and various transportation agencies where you can come test in a proving ground environment your autonomous and connected technology. And specifically at A&M, we have a new campus that's being developed called the Rellis campus. It's about 2,400 acres, and it's going to have an extensive network of technology, including virtual reality simulations and labs that are going to support on-road testing as well. So I just wanted to run through all this, and if anybody's interested, you can contact us, at A&M, either myself or Chris Poe, who's our strategic lead in connected and autonomous vehicles. And with that, I hope there's some questions on some of those cases. Yes.
So you mentioned the 99.9% reliability or accuracy with the tolling, but you always hear of false toll bills being sent or some errors in the process. Is that metric based on something different in the final product? For example, there could be an error in the administrative or some of the billing process and not the system process.
Usually, in my experience, you never send out an incorrect bill. That was the way the company I ran in that space the way we operated. And so we had a whole host of processes we would go through to make sure that we never sent out an incorrect bill. So yeah, the answer is yes, in a way. The 99.99 is really more at the lane level, because you can't get to a correct bill unless you got, really accurate, highly reliable transaction detail that's happening at the toll point. So I don't know of the situation that maybe you're referring to, but that would be kind of an unacceptable situation, much the same way that if somebody sent you a utility bill and it was wrong, you'd have a pretty valid complaint.
In terms of the automated vehicle testing, what do you see, being sort of the focus for what we're doing in Texas versus what's maybe being done in Pittsburgh, because they have different weather conditions, different geography, et cetera, et cetera?
It kind of depends on the parties who are interested in testing. So you're going to have different environments that you may want to test in. You're not necessarily going to come to Texas to test in snow, for example. But you may want to come to Texas to test in a whole host of different venues that could include anything from very dense urban environments, highway, highly congested, and to be able to move down the road and get very rural. And those rural highways have a whole host of other situations. I think in Steve's earlier conversation, he mentioned that trucks are likely to be the first, real across-the-board adopters of autonomous driving, and that's because you have long stretches of roads where you're not going to be, changing lanes and doing a whole lot of different activity when you're on the interstates between, where you pick up your load and where you're taking it. So it has a lot of different venues that are involved with this, and there's a reason for that. And I think if you look around the different cities in Texas, if you just think of the Texas Triangle, we did some work and kind of focused on three areas of that, the three apexes of that triangle. In the Dallas-Fort Worth area, you have a toll road, you have a transit agency, and you also have the North Central Texas Council of Governments that are all kind of working to work with traffic flow in that kind of market and that kind of environment. Then you could drive down, to the Austin and San Antonio area, and there you're going to have the benefit of kind of a different kind of commuter workforce with the demographics that are there with the Silicon Hills here in Austin, also with a transit agency and also a toll environment that are a little bit different, but different kind of traffic patterns and different kind of environments. Then you head over to Houston, and you got the world's largest medical center complex. You have a metro transit system plus its own toll roads, and a very extensive network of highways and then feeder streets. And all these also have underlying them multi-jurisdictional issues. So you'd have maybe a state operation, county, and then the local groups. And so there's a highly complex ecosystem, if you will, of road ownership and how all this is going to work and how you do it in a consistent way and where all these environments are best demonstrated, and so it's a challenge. You want everything to be the same, especially when you get to interstate activities. You're not, if you're in an autonomous vehicle, you're going to want that to perform in the same kind of across the board. And I think a lot of that went into how the DOT picked the 10 locations they wanted to have that kind of variety.
Even with the truck being autonomous, you're still going to have to drive. You're going to have somebody on pilot.
The future vision is ultimately maybe not, okay, but today, yes, you absolutely have to have that.
I mean, and to me, it's like a long stretch between Austin and Dallas would be 20 miles outside, and you have to take over.
And those are operating rules that people are thinking about and talking through how they actually implement those kind of things. The interesting thing from a disruption standpoint is if you can get into the platooning role, a third of the cost, an earlier speaker talked about a third of the cost basically is fuel, a third of the cost is the driver also. So you're taking the driver out of the platooned vehicles behind you. Imagine a future where you have one driver in the lead truck, and you have an ability to go off, and he's just in the lead truck, but the other ones are, driverless and actually are just following at that point in time. What you then have is a rubber-wheeled train. And you have a much more cost-effective freight consequence than you do having to put it on a steel wheel train today that are have their own different tariffs.
With one driver still restricted to the 8 hours a day, whatever the department says.
That's the hours of service issue, and if you have one driver in there and that's it, and he's driving a whole train, maybe they say, okay, you still got an 8 hours of continuous service issue before you got to take a nap, but maybe then somebody else takes over for him, he stops someplace else, or maybe he hops in to the truck behind in a sleeper situation and they continue on. So, right.
Their goal is to basically drive 24 hours a day.
Right.
So
Well,
that's essentially, well,
yeah.
it's okay because that's what you're trying to do.
Right.
You're trying to get the load from point A to point B. The only problem I have with once you get into the road, because I went out on the road with a company for a month just to get some information a couple years back, and talking about it as opposed to getting in a cab with somebody, it's a whole different picture.
Correct.
I recommended this one of the researchers that down in Arlington, that if you want to study traffic flow patterns, you need to go out with a driver for about a month and basically just watch from that bird's eye view how the world evolves around that truck.
Yeah, the question really is, how do you make sure that in a trucking environment you really capture the essence of what the truck driver has to deal with and everything? That's absolutely correct.
So there were roads we went on that basically autonomous and it's not there yet.
Yeah.
Far from.
No, totally agree. I mean, these are all pilots and demonstrations.
I agree with all that's happening. I mean, it's fantastic. But the idea is that there's still these places that they go to that are off the beaten path. Because
Yeah.
the trucking company takes jobs, and that's essentially what happens.
Right.
They take anything they can in some cases, and the larger companies say, well, we'll open this market up because I basically will just cover this and send Joe out to do this thing for a job that we're trying to capture.
Right. And then the whole network of where freight loads, how you get a freight, I mean, that was my old business, is the dating service for where you pick up your next load. So that was Dial a Truck and Link Logistics up in Canada. And so, those were huge backhaul issues that, were important. And you don't ever have necessarily the same route all the time. So it's a big challenge. But there's also scheduled routes and planned routes that some carriers will follow because I'm going to take these trucks from here to there, and then I'll have a backhaul, and they get some kind of service contract with the different shippers that they're working with.
Is there anything happening with embedding technology inside the road?
The questions about embedding technology inside the road, there's a lot of conversation about that, everything from electrification to, and I'm not just talking solar roadways, but I'm talking about kind of a rail to help, for electric vehicles and recharging, for communications and other items. And the answer is yes, everybody's talking about that, but it's an engineering and a performance and a business case issue that people are dealing with a lot. One of the questions I get all the time is how come I can't use my cell phone to pay tolls? And if you just think about the tolling at the level of accuracy you have to require for it all to work. If you got multiple people in your car whose phone is paying the toll, and here's the reality is the operator of a toll road is typically going to be kind of a government institution, and they're going to have limited operating funds. So when you start introducing a lot of variability and unusual occurrences that take a lot of time for people to address, if you don't want to have any errors in the system, the RFID devices or some other kind of communications device that's permanently affixed to the car, so that's because that's the entity that's being charged the toll. You take this variability out of it, and you can start running a very lean, operational, low overhead kind of environment, because you don't want to have to look at a whole lot of transactions and figure out, what the answer is.
Wouldn't it be more cost effective, Well, you said revitalize the roads, I mean, that would be part of the scheduled maintenance program, right? But once the rebuild starts,
Right.
because it's like 3,200 miles and
Yes.
cost per mile.
Right, and that's kind of what people are talking about. I mean, if autonomous vehicles all showed up today, no one's going to go out and change everything on the road overnight. Yeah, couldn't afford it. But what they may do is they may go out and re-lane it, restripe it, for the lanes, and they give some thought to a whole lot of things like the geometric curves that you're going to have, and as you're going up and down, and turning. What's the gradient you're going to have, the road geometry. There's a whole lot of things that people are starting to now think about that, hey, maybe we need to think about doing those things a little bit differently once these are all autonomous vehicles on the road.
But these are plans. See, we were discussing the thing in Arlington, that the vehicles came up. They're not implementing, the key is they're not even looking, at least what they understand was they're not actually putting this in the forethought of the designs for the future roads.
Right.
Right now, Dallas is revitalizing its road system, but that's something that probably came about 3-4 years ago, and it's totally out of date right now.
Exactly. And that gets back to the procurement issue, but you're right, you still got to deal with today and what's going on today, maybe with the view to the future, but you don't know what that is. An earlier speaker put up the levels of automation. Goes from 0 to 5. We're at level 2. NHTSA, which is the regulator for highway safety, we're at level 2 for the most part across the industry at best. And there's a lot of vehicles on the road that are level 1 and 0. So when you think about that in terms of the number of vehicles that are going to be on the road today, it's not really an issue. It's an improving stage, piloting, but it's going to take a while to convert and change out vehicles into fully autonomous mode, and then over time, if we fell asleep and woke up 50 years from now, it'd be a whole different story, I would think, and you can quote me on that and prove, I can prove it right in 50 years. But, in 50 years from now, we're going to have gone through that transition. Yeah, we'll have gone through the transition, and it'll be a different, that'll be the new normal. And things will move faster than I think all of us think they will, because things just move that quickly these days. There's too much interest.
We will get to level 5, or at least in the U.S.
Not, I think entirely, it's going to be at least, I would think it's at least 20 years, but there's going to be some people that will be out there operating in level 5 mode, even if they have to have a person in the driver's seat, for optics and for regulation and so forth. But that's a hard prediction to make.
So he was talking about level 2 and level 3. There's a real problem with the systems taking over and the driver becoming inattentive. Is that something you've looked at?
It's a huge issue, and there's a lot of people who have been discussing whether you can go and give the control back to the person. Just think, for example, if you've been in those cars that have the rear cameras, and if you're backing up, if you're a rental car, you see a rear camera and you start using it and you back up by looking at the video screen, it's great. But then if you're doing it without that, you've kind of dumbed down pretty quickly, and you're now, I forgot how to look around and make sure I'm safe. There's a real human factors issue with how quickly people can regain control. Plus, if you start automating some of that technology, with regular telephones in the old days, I knew telephone numbers in my head, and I could just dial them. I can't do that anymore with a cell phone because it all does that for you.
Yeah. That seems like a very big problem. The very thing you talk about, human engineering, because we are not going to be paying it. If we're taken out of the pay attention to everything that's taking place, it's going to take us a moment to go, oh, I see a problem, and I've got to take over. And then you got to calculate what's going on, what the speeds, what the distances are. That's a recipe for disaster.
And we just heard the last speaker talking about, close your eyes for 5 seconds, and you got a problem.
You effectively do the same thing. That's a good point.
Well,
You've got something taking over for you.
Another study, and I don't know if these are the same metrics that you'd seen, but you are 6 times more. It's the equivalent of being 6 times more inebriated beyond the legal limit through that distracted
5
drive.
seconds at 40 to 50 miles an hour, you've gone 2.5 football fields while you glance down and do your text.
2.5 at 65?
Yeah, it's a
That's what happens.
Think about that in the city.
Oh, yeah.
yeah, it's a dangerous thing.
So my comment is that Texas was one of the first states to pass the bill around, or at least propose a bill around banning texting and driving, but not other states have, and hasn't come through.
We still haven't done it.
I think we were the first ones to come up with the idea of doing it.
Yeah, but we didn't pass it.
We didn't pass it.
Yeah. So what's up with that?
Okay, I'm a native Texan, but I actually live in Wyoming, so I'm not familiar with that, with the politics here. But if I had to venture to guess, the bill has its merits, right? But the reason why it doesn't pass is because maybe we're not going to regulate people's lives, and somebody doesn't understand that it's not just the people in the car, that are distracted. It's who they're going to hit that are, that's the problem.
These guys behind it, the AD&D and everybody's behind it. Let's keep them texting.
No, absolutely not. I don't think it's them. No, I don't think so. They have a lot of public service commercials against that, and it's foolish. And there are some apps, I think, that can let you disable the ability to text if you're in motion. Yeah, let us know, and we'll be happy driving around you then. Any other questions? Okay, thank you very much.